All right, like I said, this is a recording, so if y'all don't want to be recorded, let me know. I have to stop it. But this is going to be a review for the upcoming first test. Remember, it's 4 tests. This is going to be a review of the first one. All right. Like I said, y'all did elective, so y'all should be pretty good with this. This is my opinion. That's what I want. That's what I wanted. See, that's what I want to do, because I want to do that. It's much easier with that. Alright, so the terminology variation, we already said this earlier. Voltage here is electrical pressure. Alright? Pressure meaning it will push current, right, which is amperage, through a amperage is inductance through a resistor. Which is an impedance. Every circuit has resistance. Okay, now y'all get stuck on something, don't understand something, let me know, so we can explain it. Because if you don't know it now, you might not know it in the test. So if you have a question, let's say something. You can stop me. Alright, and like I said, the reason I told you before why I'm recording this, because it's going to be on the test some type of way. So if you have to say something, stop me. Alright. So like I said, every circuit has some type of resistance. For example, if I have a 12 volt circuit, this load, which is the bulb, my favorite drawing, has some type of resistance built into it when it was engineered. Alright, it could be 2 ohms, 4 ohms, 8 ohms, it all depends what it is. It has a built-in impedance, resistance for that circuit. Ohm's Law states that current through a conductor between 2 points is directly proportional to the voltage across the 2 points, introducing the constant of proportionality that the resistance one arrives at the usual mathematical equation that describes the relationship. And like I said earlier, remember I said before, Ohm's Law is just a theory, a concept, right? You use the concept on the car. We don't actually go to a car to use do math. We use the concept to find problems. And how we find that is the relationship between voltage, amperage, and resistance. I'm going to show you an example here in a second. Like 1 equals 1 times 1, right? And so we have here, we have voltage, amps, and ohms. Relationship only on complete circuits. Now this is a key right here. Oops. I guarantee if you don't know what that means, you're gonna get at least 3 questions wrong. Can anybody explain that? Ohm's Law and complete circuits, how that statement relates to each other? Anybody wanna give it a shot?
The complete circuit is getting the full total of amperage, resistance, and voltage.
Right. It's like, I think he's saying is this. If I have, I should come write the screen. If I had 12 volts in the circuit, or 14 volts in the circuit, and I have my load, and I have a ground, that's a complete circuit, right? Current is gonna flow through that circuit. I'm gonna have my 12 volts. That's my resistance on the load device, which this is the load device, which is the light bulb. Alright, and I got a path to ground. Remember, to have a complete circuit, we need voltage, a load, and a path to ground. Okay, to have a complete circuit. If that circuit does this, oops.
That's an open circuit.
What's that called? What's this called here?
Open
Yes, this is a open circuit. Okay, that's an open circuit. Now, with an open circuit, what happens? That's the key to answering 2 questions on the test.
Voltage drop.
Right, you had you had no voltage drop. All you had was potential voltage. So if I check with a meter here at this point, put my meter here and check it, I'm gonna have what?
12 volts.
Yes, 12 volts. Right? On the other side of an open, you know what? Let me explain it this way. Let me explain it a different way, because this might not make sense. Oops, no. We did something like this earlier. All right. Again, we had 12 volts you just said if I had here, right? Now, according to Ohm's law, I'm going to drop this voltage all the way down this line. So each one here, I should have a voltage. We ain't going to figure that out yet. We do that later. Okay? We should have a voltage. But if I have an open circuit, crap, I did that wrong. If I have an open circuit, here, I would have 12 volts. Zero and zero here, right? Because it is open. That's an open circuit right there. I'll have voltage there, 0 and 0. What would the amperage be on this circuit? The amps will be
3, 1.
no, 0. This one statement right here, the only way you're going to have a voltage drop and current in the circuit has to be complete. Remember, the only reason that you see voltage here in that box there, the only reason you see voltage in that box there, right, because that's called, anybody remember the name of that? The term I said earlier? What's it?
It's source voltage.
Source voltage or potential, because between those 2 points here, there's no break. Right, there's no break. I'm saying potential or the source voltage, like source voltage. But at this break here, right, voltage stops. So on the other end of it, it's going to be 0. And in order to have current in a circuit, you have to have a complete circuit. Now, again, refresh our memory on Ohm's law. So anyway, anybody got, before I go any further, anybody don't understand that? Because if you don't, you're going to miss at least 3 questions. Everybody, no questions on that?
A complete circuit is the longest enough that doesn't have no opening in the complete circuit.
Exactly. A complete circuit had a path from source to ground. You can have a battery, source voltage, a load device, and a complete path to ground. Now, obviously, in a real circuit, you have switches and other things too, but just a basic circuit. You have source voltage, a load device, and a complete path to ground. All right. Missing any one of those things, or becomes open, current, you don't have a circuit, or current won't flow. So remember, on the test, they're not going to ask you that. They're going to ask you, okay, they're going to give you a diagram and says, what's this? Or what should you see here? Like I just did. Now, on this picture here, it's showing you the Ohm's law symbol, which relates to this. Voltage is amperage times resistance, gives you voltage. So if I want to find out the voltage in the circuit, I'll have my amperage times resistance. Okay? And usually what you want to do is, if you have 2 known factors in the circuit, you want to find out the third, cover up the one you want to find out. Like, for instance, this one for voltage. I don't know if this is going to do it now on this. Let me see. No, that ain't going to do it. So let's say if I wanted to find a voltage on this one, I would cover this up and do the math equation. Right? I would get voltage times amperage times resistance gives me voltage. The next one, I want to find amperage in a circuit. I get rid of amperage, and it's voltage divided by resistance gives me amperage. The last one is voltage divided by amperage gives you resistance. So again, I want to find out my resistance in the circuit. So my voltage divided by amperage gives me resistance. I want to try and make a blank page. That's the only thing I don't know how to do in this yet. To give you examples, I want to make a blank page. I gotta figure out how you do that.
On the cross, Mr. Nate.
Pull library, scan GIF.
On the little pages thing.
Oh, where? This one? That's just, oh yeah, blank. Hey, you're a genius. Gabriel, you're a genius. You know how long I've been trying to figure that out?
Damn, Gabriel.
I know. I should carry him around with me. I've been trying to figure this out for the last, I don't know, 6 months, a year almost. Messing with this, no, probably 6 months to 6 to 9 months. How do you do that? All right, I'm gonna give you some examples now. Now, remember, if you get confused, let me know, because a couple of the examples are going to be on the test. I ain't going to tell you which ones, but they're all going to be on the test. So if you're confused, say something. Now I always draw 12 volts. Assume you know that's a battery, right? Right, it's 12 volts, positive and negative, which is my ground. Okay. But on the reason I'm saying, because on a test, you're gonna see this though. I should draw like see on it. You're actually gonna see this. And that represents what? Anybody know?
Ground.
Oh, actually, the ground and positive. The small one is ground. The big one is positive. The place for a battery. So it represents the battery. So that's good. So that represents the battery. You're going to see that. That sucks. You're going to see that. So, example would be Ohm's Law. This is my light bulb. Who's that? All right, this is my light bulb. Okay, let's make it easy. I got a 12 volt battery. This should be easy for y'all, especially if you did electric. All right, what's the current in the circuit?
3.
3, right? 3 amps. Pretty simple. Oh yeah, what type of circuit is this anyway?
I don't know. Series.
Series. It's a series circuit. All right. Now, I'm gonna put a voltmeter across it. I want to see a voltage drop. All right. And remember, a voltage drop represents the difference between the red and the ground lead, the black and red lead. See this? That's my red lead going over here. This is my black lead going over here. Should make that box bigger. So the leads represents the pressure differential between the 2 points, or the pressure difference between the 2 points. All right, but in Ohm's law, we can figure that out. We can figure that out also. So if I have 3 amps and 4 ohms, the voltage drop across that one bulb is what?
12 volts.
12 volts, exactly. 12. That means that one light is using up 12 volts. And according to Ohm's law, if you have one load in that circuit, all the voltage should be dropped across that circuit. I mean, that one load. I'm sorry, it should be dropped across that one load. For example, if I put a meter here and check for my available voltage going up to the load, it's going to be 12, exactly. On this side, what's the magic number?
Close to 0.
Close to 0. Near 0. Right? And the reason why it's near 0 because all the voltage was used up across the load device. So on the ground side, if I have a clean ground, I should be 0.1 or less, especially for metal. Any questions before I erase it? Give you the next example.
1 second. Don't move. Go ahead.
I'm gonna write 12 to give myself some space. You know what? I made a mistake again. Kind of opposite. You can deal with it. Now remember, this is still a series circuit. At the bottom are voltmeters. Alright, at the bottom is voltmeters. Okay. Now also, for the new people who just started, I hope y'all ask some questions, because I know this might be a little new to y'all because you just started. So ask the question, because you might not hear me say it again. All you have is this video. So if you have a question, make sure you ask. And you're gonna take the same test. Now remember, this is a series circuit. Okay, still a series circuit, because remember, the loads are right behind each other. All right, they're right behind each other in one straight line. Now, I'm missing my amperage in this circuit. My amperage is the question mark. Alright, I need to know the amperage in the circuit. And again, remember, we have to follow this rule. We still have to follow this rule. Okay. Now, since it's a series circuit with more than one load. Yes, thank you. That was Mr. Garcia, right? Thank you. Yeah, we have to add them together. Okay, you know what? Let me make the math easier. I made a mistake. I'll make the math easier. So we're going to add them together. So we got 4 ohms. We got 4 ohms and 2 ohms. Okay? We had to add them together, like you just said. Six ohms now. Okay? Now, what we need to do, what's our next step?
12 divided by 6.
Right. Since we want to find our amperage, it's voltage divided by resistance, the total resistance, which is 6 in this case. So it's 12 volts divided by 6 ohms equals 2 amps. So our amperage in this circuit, is 2 amps in this circuit. Can I move that over? I'm gonna try something. Look at that. I can actually move it over. I'm getting excited. Y'all seen that?
You're good.
Obviously, y'all realize I'm learning how to use this iPad at the same time with a presentation. Alright, so now, so it's 2 amps in the circuit. Okay, so I want to do a voltage drop across each light, each bulb. Basically, what I want to do is see how much voltage is being used up across each load device. In this case, each light bulb. I'm gonna give you a test question. Every time I say it, I start in my head. I start laughing. If y'all miss this symbol, they ask you what that's called, and you miss it, you wasn't paying attention at all. I don't know how many times I said that.
What is it, Mr. Neat?
I don't know. Somebody tell me.
Light bulb?
Exactly.
Load, there's a light bulb, a load, or resistor.
Exactly. Y'all missed that. Y'all wasn't paying attention at all. Every time I say that, I just laugh, I smile. Okay, anyway, so I want to do a voltage drop across that bulb or that load device. Okay, remember, I'm gonna hook up a meter. How is this meter connected? It's in series parallel or series parallel? The voltmeter, my pretend voltmeter I have here.
Parallel.
Thank you, parallel. It's hooked up in parallel. Got one lead here. The black lead goes to the other end. Now I'm checking the pressure differential between the two leads. Okay. Now we're gonna use Ohm's law to figure that out. So it's another rule. Here's another rule in a series circuit in Ohm's law. Let me erase that. Let me put that back. Anybody remember the rule of amperage in a series circuit? What's the rule with amperage in a series circuit? Yeah, I did an exercise on this earlier. In other words, say it again.
It's always the same.
It's always the same, exactly. So if I had 2 amps here, I'm gonna have 2 amps going back. Okay. Whatever leaves the battery goes back to the battery. All right. The amperage leaves the battery, do some work, and go back. So now, with that said, that means I actually had 2 amps flowing through each light. Okay, so I had 2 amps flowing through each light bulb. Now, I want to figure out how much voltage is being lost across each load device. And to do that, my question is, I want to figure out the voltage. So this is what I want to figure out. So my math formula is amperage times resistance.
Mr. Neat.
Yes.
So
Who this is? Gabriel? Who's that?
Garcia.
Garcia, yes. Say your names so I know who y'all are also. I can't see y'all.
Voltage, it just goes to 12 volts, right?
I'm sorry, say it again.
The 12 volts goes to the first voltage series,
Go to the first load, you mean? Yes.
and then from there you do the math.
Yeah, it goes to the first. Yeah, you're right. It goes to the first load device. Yes. That's a good question because yes, that 12 volts he's talking about here goes to the first load device. But before we talk about that, I want to see how much voltage each load device is using out of that 12 volts. And at the end, since you mentioned that, at the end it should total 12 volts.
The first one's using 8.
First
8.
one is 8. The second one is 4.
It's 4.
Okay, now how did you get the? How did you get the 8?
2 times
4 times 2.
Now who was that saying that? Was that Ricky?
Ricky. Yeah. 4 ohms times 2 amps.
Exactly. So it's 4. Number 4 ohms, what you got here, 4 ohms times the amperage equals an 8 volt drop. And you do the same thing with the next one.
2 times 2 is
You do the same with the next one. Amp stays the same, so it's 2 amps times, what was it? 2 ohms
2 ohm.
equals a 4 volt drop. Right, so you can see that the one the highest resistance uses 8 volts, and the other one, the lower resistance, uses 4 volts. And you add them together, you can see it totals up to 12 volts. All right, now since we have that down, now let's do this. Everybody good? I'm actually talking to the new students. Y'all good? Okay. How about you? Who's the other one in class? Sergio, are you good? Sergio, are you there? Eric, how about you?
Yes, so I'm good, Mr. Nate.
All right. Sergio, are you in class? See, that's why you're supposed to have your cameras on.
Yes, I'm in class.
Okay, thank you. All right.
My computer.
All right, no problem. I should have delayed anyway. I forgot this delay on my end anyway. My bad. I forgot I had to, this delay pause we have to do. I forgot. All right. Let me see. What's I'm doing? Okay, now since we did that, I think this is going pretty well so far. We go into this first here. I think it was Mr. Garcia, Mr. Garcia said this. That first box, 12 volts, is receiving to that first load device right here, right? Because here there's nothing in the way. That's source voltage. Okay, there's no load dropping the voltage there at all. So I'm gonna read source up to that first load device. So I'm gonna have source voltage all the way up to my first load. Right? It's gonna be source voltage all the way up to that first load. Okay. Now keep this in mind. This first load here that's used up how many volts?
8.
8, exactly. It just used up 8 volts. So if it used up 8 volts, how much coming out of it? Well, 12 went in, it used up 8. How much coming out? 4, exactly. 4 volts. Now, on that end there, 4 volts is now going to the second load device, which is a 2 ohms. So now I got 4 came out. It's going into the second load. That's using up 4, we figured out. What's left over after that one is going to be what?
Nothing.
Right, exactly. Near 0 volts. I think this is working out way better than the other thing I was doing. Y'all like it this way so far? Is this working for y'all?
Yes, sir.
Using that mouse was killing me. All right, so that's good. Now, here's the thing. You might want to say, what in the world? All right. I'm going to try something here. Mr. Garcia, you might have to help me here. Oh, shit. Oh, it actually worked. Let me write this out. No, I'm going to put 2 of these stickers up there now. How did we do that? You hit the plus. Was it plus, wasn't it? Plus, sticker.
No, on the.
What was it?
On the little pages.
The little what?
Pages in the corner.
Oh, pages in the corner. No, it wasn't that. Was it that one? No, I don't think it was that one, Garcia. I think it was the plus side. That's the one I did first. I think it was the stickers.
Blank.
Yeah, it's the stickers. There you go. And the reason I did the stickers up again, I want to compare the two. Now I can't move no more. All right. So now you might be wondering, okay, how does it relate to a car, to anything, or to these lights? What does this mean? Okay. Now, let's say that I have 12 volt. Golly. No, I don't want that color on the same. Let's say I had 12 volts. Okay. I'm just redraw it. Draw this again. Oops.
We should try one with not a whole number.
Hold on 1 second. Oops.
You're thinking out loud, sir.
Thanks. So I'm trying to make the math easy, so you have to pick up a calculator. Like what Garcia just said, try not a whole number. Yeah, you're gonna have to pick up a calculator. I'm trying to do something you can do in your head. But when you do this, you
Appreciate that.
yeah, thank you. You're welcome. This one, I don't want to be like a let to. You got to pick out a calculator and a roll of paper. All right, something easy for right now, anyway.
Any hard ones, if you don't know about the test, how hard it's going to be.
Well, I know how hard it's going to be. Trust me. I'm trying to stay on. I'm glad you said that. I'm glad you said that, Garcia, because I know it's on the test, and I know I'm reviewing for. Like I said, I'm reviewing this for you for the test. So I'm trying to stay on that subject of the test, right? So trust me, I got you. If it's hard, if it's a hard one, you'll see it. That makes. I was around. I hope that makes sense.
Don't throw a cross section.
Okay, it's almost basically the same circuit. Almost. Except we have corrosion. Oops. We have corrosion here. Now you can't measure corrosion at all. But I use 6 ohms just for this mathematical formula, just so you can see the difference. Okay, now how you find corrosion or find a problem in the wiring is about what we're doing right now on this sticker. Actually, I'm gonna show you in a second. Okay. Now it's the same circuit, except let me see. no, number one here was a good circuit. Number two has a problem. Now, since we have resistance in line with the resistors, it still makes it a series circuit. So our amperage in this circuit is now what? With that corrosion?
1.
1. Now, you see what happened already? What just happened from the good circuit to this bad circuit?
Our amperage drop.
Our amperage drop. Remember the rule. High resistance, low current. We talked about that before. Oops. Shoot. Higher the resistance, the lower the current. They in proportion of each other. So now we know our current just went down. Okay, now what's the in this first box? What's there? I just put the V at.
12.
What? 12. And the reason why there's no resistor in the way, not yet anyway, right? So I still see source voltage. That still sees 12 volts source voltage. Now on the first one, the first drop, how much you see there?
That's in that fact is the first one it should be 8, but now it's 4.
Right now it's 4. Now it's 4 volts. And like you said, and you're right. Like that was Garcia, right? Said that right. Like you just said, my 8 volts in the good circuit just went down because of the resistance.
Now you add them up together and you're gonna get 12 volts.
Well, all right, hold on 1 second. How about the next one? 2, exactly. Now you see, according to the math, or the theory, it's only 6 volts now, and before we said it's supposed to add up to 12. Hold on 1 second. Go ahead, trying to catch this dog. I hear all this noise in the microphone. Now I gotta cut that out, edit it out. All right, so. All right, with that, okay, we'll be back. So we got 12 volts going in. So we got 12 volts going into the first light, right? Now in this,
Does the corrosion take the other 6?
yeah, yeah, that's very good. I'm gonna show you. All right, that's a very good observation. I'm gonna show you how. So we got 12 volts going into the first light, right? But now it's only using up 4. So what's coming out?
Below, close to 0?
No, in this box right here. What's coming out in this box here?
1?
No, you got 12 going in.
Oh,
You 8. There you go. 8 coming out. So 12 went in. 12 went in. Minus 4. 8 is coming out. Right, 8 is coming out. Okay. Now,
Why at the bottom do we get 4?
how we get 4? Oh, that's a good question. We have 1 amp. We had this 1 amp here. 1 amp in a series circuit. So you got 1 amp flowing through this whole circuit back to ground like we talked about before. Right? So 1 amp going through that first load. So 1 amp.
No, I get that part. 1 times 4 is 4.
Yeah.
But talking about when there was no corrosion, we only dropped 4 to the box on the bottom, making the bottom.
Yeah, because 8, because a load device, he talking about this one. Because the load device used up 8. And so 12 from 8 was 4.
But remember, we only have 1 amp because because of the corrosion.
Exactly. So now we only dropping 4 volts. So you got 12 going in. That bulb's only using up 4 volts, 8 coming out. So now the next one, which is this one, right? We got 8 going in. See here? You got the 8 going in. We got the 8 going into that load. It's only using up 2 that y'all figured out. It's only using up 2 volts to work. So what's coming out? 6. Now, remember this, I said this earlier in the class. I like this one. It takes 1 volt to push 1 amp through 1 ohm resistor. I like that term. The reason why? We need voltage to push current through a resistor. Anytime you have higher than 0.1 volts on the ground side, that means you got unwanted resistance down the line from that voltage, which is that corrosion. So in other words, I need that voltage to push the current through that resistor. So I'm going to take it from the other 2 circuits, other 2 loads.
Now that could also be a loose connection, right?
Yes, it can. You're very right. It could be a loose connection. It could be freighted connection. It could be corrosion. It could be a pin pushed not all the way in. Just barely touching. Right? Anything that causes resistance or bad contact, that can happen. And like I said earlier, you can't find resistance. It's hard to find resistance unless it's obviously blatant in your face. So a voltage check, like we just did, will show you the resistance. So that 6 volts on that ground side proves there's a resistance on the ground side. So let me ask you this question. Since we got 6 volts on the ground side, how would those 2 load devices act since they lights?
Low. They would be low. The bulbs wouldn't be as bright as they should be.
Exactly. They'd be dim. Right? They would be dim. Okay? So imagine somebody's coming in and say, "Oh, my lights are dim." Right? And the lens is clear. Right? It ain't because of it's not because of a foggy outside lens. It's just dim all the time. He said, "Okay, I picked 2 new."
Yes, usually one light, say one headlight is bright, and then the other one is dim.
It's dim, yes. Indicating that's a problem somewhere. All right. I'm sorry, who's that?
I had a customer, well, not a customer, a friend of mine that was fixing electrical in his car.
Yeah.
And for some reason, well, I know the reason, but the right headlight would turn on, but the left wouldn't work, and he put like 3 new harness.
Uh-huh.
And it's like, now you know why. It's just, you're not, there should be a corrosion or something.
Yeah, a wire or corrosion problem somewhere. I'm trying to get this out. Take a snapshot of that. Any other questions? So everybody got that? All right, so that's like a mess, don't it? It's a mess up there. So, okay, one more I want to show. I'm going to erase all this. So I want to show you one more thing here. This thing don't have a quick erase. That's the only thing. At least I didn't figure it out yet.
Gabriel, how do you quick erase, Gabriel?
Just drag your eraser out through the screen.
You like this?
9 is playing, I don't know.
Thanks.
Mr. Dave,
Yeah.
It could be a short too. Anything that happen with the short?
What you mean? What you mean?
Like if you have any short in your car, anything like a wire touch another wire.
A short. If a short, if a ground wire shorts the ground, really nothing happens unless it's ground control. But if a positive wire touches the ground, it's gonna blow a fuse. That's an open circuit. all that beautiful math is gone now. All right, I want to show you this. Let's say, let me give you a hard one since Gabriel asked for one.
Let me get my calculator.
Stickers. It's a sticker, right? Blank sticker. Ah, you son of a gun. Hey, I made a big one. Live and learn, huh?
Oh, that's nice. How do you do that?
I don't know. I just drove the corner and did this. Hey, learn something every day.
I had said that you could drag it.
You learn something every day. I'm gonna give you some this request by Gabriel. I thought this in my head.
These gotta be one with a right answer. Not like stop thinking that you gotta take or add.
Oh, now you're being picky, right?
Serious. Or 8, 10, 11, 40.
You stop for him to finish.
Say it again. All right. Let's figure out this one. How many amperage in this? What are you missing now is the amperage.
5.
Very good. 5 amps. Exactly 5 amps.
The first one is 20 volts.
20 volts. Let's do it like this. A, B, C, D, E. Oops.
Mr. Nate, there are
Yes.
what circles before the first resistor.
Oh, it's a switch. Thank you. Switch. That's a switch. All right, so you're right. It's 5 amps. We got the switches closed. The switch opens and closes the circuit, so the switch is closed right now. So you had that. So now, I think what Mr. Ricky said, the first A is what you said it was, Ricky?
20.
20.
B is 10.
Next one is 10.
C is 20.
And C is 20. If you did it correctly, they all add to 50, right? Now, how about D?
16.
30.
No, wait. 30, yeah, my bad.
30. How about the next one?
Gabriel,
On the next one?
20.
20. The next one?
0.
Near zero.
Near 0. Very good, y'all. Any questions?
That was pretty good. That was pretty easy.
All right, now I'm going to do...
Ricky, I get it, but I get the wrong answers. I don't know why.
I know you do, man. You're good at this. It's because you hurry. You're like at those games, those
No, not doing the open circuit, guys.
Ricky said the truth, man, because you go so fast. That's why you try to do before he finish.
Yeah.
That's what happened. Hey, say the truth, man. Come on, Gabriel.
Come on, ain't good.
Ya te lo dije.
All right, how about this circuit now? I just changed the circuit now. What you see here?
Open circuit.
open. It's an open circuit.
All right, so what's A?
Let some of the new people try and see what they come up with.
That's good. That's good. Okay, youngsters. I mean the new people. I had a wash machine on the microphone. I had dogs running around on the mic. All right, who? All right, y'all still on? Put y'all on blast.
I threw them under the bus. I'm sorry.
Y'all want to try it?
Now you're gonna help him, Ricky.
Eric, Sergio, Maria, y'all want to try it?
Yes. Help us out, Ricky.
I'll give you a hint. I'm gonna give you a hint. It all counts on this one thing that happened here. The answer relies on that. And we talked about that earlier. Don't worry, I won't put the guys up in here in a long time. I won't put them on blast next. Since they want to put y'all on blast, I'll put them on blast next. The next one's for them.
Oh, come on, Gabriel.
Come on, Ricky, help him out.
Okay, help them out, y'all. What's this called right here? When the switch is in that position, what's that called? It's an open circuit, right? And we said this earlier. In an open circuit, there's no current flow.
So we're on.
No current flow, and no voltage drop. So
ABC, everything's zero.
everything is 0.
I helped you guys out. See?
Everything is 0. All right, because in an open circuit, everything stops. So that's the first thing we said when we started this. All right, or to have a complete circuit. Remember that rule? What is it at? Where did it go at? Oh, it's under the picture. Oh well. Right. Right. When you have an open circuit, no current flow, then you have no voltage drop. But you might have this though. You want to put a meter right here and check at that point? Would that be 0 also? That'd be 50. The reason why? Because it's before the open. The reading is before the open switch. Yes. I can't hear you. Drop down.
You think I could? Oh no, you're erasing. I wanted to show you how to erase everything in one.
Oh no, you can show me in a second. I don't want to erase everything right away yet. I want to show this. The next one's for y'all. That's why.
That's why I want to erase it. He's gonna do an open circuit. I'm gonna go and do it.
That's one thing about this. All right, now this is for the people who've been for a while. What's the answer here?
0.
You think everywhere?
No, not everywhere.
Where?
Wait, isn't the open circuit after all the math?
I'm not saying. You gotta look at the
So
picture.
you keep going.
Y'all could talk among yourself.
Ricky, the open
Yes.
circuit is in the back, in the end.
Yeah, but it shouldn't matter because it's still not a complete circuit.
Is all 0?
Wait, I'm trying to figure it out. Hold on.
I'm thinking it's.
See, if it was a switch, well, no.
You know what? It's not. You know what? There's no amperage.
Come on, Angel. Come on, Angel and Robert. Get in this conversation. Y'all been here long enough.
Hey, Ricky. The amperage. There's no amperage.
Yeah, that's what I'm telling you. There should be zeros. I just need someone to back me up with it.
Come on.
there's new students.
Come on, Robert and Angel. Come on. Help them out.
Thinking about it.
It should be 0s because it's an open circuit.
Now, see, like D, E, and F. Wait up.
It's 0s because it's an open circuit.
So is he saying 0 everywhere?
Yeah. You can't do the math if you don't have amperage. Amperage is 0.
Oh yeah, I forgot to erase that. Yeah.
He's telling you.
I'm sorry. I forgot to erase that. Sorry.
It's 0s, bro.
Who else? Why? We got Ricky and Gabriel. Who else? Zeros.
Yeah, I think it's 0 too.
So,
All right, Robert.
what you think, Angel?
Angel, what do you think?
You can see it too, because it's open. No matter what, you can get anything from there.
So A, B, and C is 0. D, E, and F is 0. That's what y'all saying, right?
Yeah.
I got a slight. I don't know about D, E, and F.
Everything is 0s because you don't do math. How are you gonna do? Everything is not 0s.
Yeah, but you see how the ground, the voltmeter's ground, and there's a ground on the voltmeter, and you got there's no current flow.
There's no current flow. It's 0.
I'm going with zeros.
All right. And y'all was half correct. That was good though. Cause this is how you write. This is where you write at. This is 0. This is 0. This is 0. And you're right, it cannot be a voltage drop or current because the switch is open. When that switch is open like that, oops. You're right, when that switch hasn't open,
Oh, so VE and never 50.
right? You're gonna have no voltage drop, no current. But on the bottom, it's checking for the potential voltage. Right? You was close. Y'all almost there, right? So this gonna be 50, 50, 50. And the reason why, because this 50 volt hot right here is on this line, it's gonna go straight through and not drop up to that point, up to the open. It ain't gonna drop. But on this side of it, it'll be 0. That's really good, y'all. That was real good. Anybody have any questions on it? Now, again, here's another rule too. Anytime you have source voltage on the ground side, you have no ground. Every time. If I have source voltage on the ground side, you have no ground guaranteed. I had to throw a twist in there. I thought that was pretty good. That's why I like using this pen better than a Zoom pen. That's much easier. I think they came out much better. What y'all think? They came out. How y'all think they came out? I know. And Tom actually went past fast too. We gonna.